Hello everyone, this video is on Unit 1, Standard 1, and this is a pre-calculus review on exponential functions. So what we're going to do is talk about graphing exponential functions, how to solve them. This all should be reviewed from your former math classes. So first of all, you should remember that to the negative exponent means the same thing as 1 over to the positive exponent. And you should also know that anything to the 0 power is equal 1. So here's some examples so you should remember, just to review, to remember how exponential functions work. You should know that 2 to the 5th power is 2 times 2 times 2 times 2. And when you do all that, you get 32. You should know that 4 to the negative 3 is the same thing as 1 over 4 to the third, or 1 over 64. Okay. You should know that 5 to the 0, again, anything to the 0 power is equal to 1. And another exponent rule you should know is 2 to the 5th to the third power means the exact same thing as 2 to the third power over 5 to the third power, which is, again, the top is 2 times 2 times 2, which is 8, and the bottom is 5 times 5 times 5, which is 125. And then this one is a little bit tricky for some people. It's 1/3 to the negative 4th. So what that means is 1 over 1/3 to the 4th power, right? If you have another exponent, you can put it in the denominator. And then this is going to be 1 over, and then this is 1 to the 4th power and 3 to the 4th power. So I'm going to do 1 over, and 3 to the 4th power is 3 times 3 is 9, times 3 is 27, times 3 is 81, like so. And you have a fraction over a fraction within a fraction. You should know you just flip it. The answer to this one is 81. So hopefully you all remember the basic exponential rules. Okay, so we're going to skip over this middle part and jump down to the bottom where it says graphing an exponential function. You should know that an exponential function, the definition of exponential function, is any function that's in the form y equals b to the x, where you have some number and it's to the x power. That is an exponential function. If I say like, hey, what's an exponential function? It's a number to the x power where the number is greater than 0 and it can't be 1. So the base can never be 0, 1, or negative. Okay? So first of all, this one is an exponential function, right? Here's your number. It's to the x power. This is not 0, this is not 1, and it's not negative. So how do you graph a negative how do you graph an exponential function? So just like what you've done in algebra, here's my table of values. You also learn in calculus, you have a graphing calculator, you can use that as well. So this is 1/3 to the x power. So if I plug in a 2, right? If I plug in a 2, I get 1 to the second power over 3 to the second power, right? Which gives me 1 over 9. So in this very, very tiny box, I'll write 1 over 9. And I don't have to do the whole thing for you, but I'll just explain to you. To the first power, 1/3 to the first power is 1/3. If I put in a 0, I get 1. If I put in -1, okay, this is where it gets tricky. 1/3 to the -1 is the same thing as 1 over 1/3 to the 1. 1/3 to the 1 is 1/3, and again I have a fraction within a fraction, so I flip and multiply, so this just becomes 3. And by that same method, to the second, or to the -2, is the same thing as 1 over 1/3 to the second power, which is the same thing as 1 over 1/9, which is the same thing as flipping and multiplying. You get 9. So that's how you do an exponential function. Now, if you remember from algebra, now I could graph it. So 2 is 1/9, and some of you are saying, like, how do I do 1/9 on a graph? Well, 1/9 is very tiny, so I'm going to go 2 and -2, 2 is 1/9. So 1/9 is very tiny, so you see that that dot is 2 1/9. 1 is 1/3, 1/3 is even bigger than that, so there you go. At 0, you know that it's 1. At -1, you remember it's 3. So 1, 2, 3 goes right here. And -2, we had 9. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's not even off the, it's like right here. So an exponential function, what it looks like, you should know the shape of an exponential function looks like that. Okay? Like a exponential function, like a half a parabola, but it peters off at the end. That's what you call an exponential function. Any function that has a number to the x power looks like that shape. Now, here's some multiple choice questions. If the equation y equals 4x's graph, which of the following values of x would produce a point closest to the x-axis? Okay, so which of these will be closest to the x-axis? So what we're going to do is we're going to make the graph first and then figure it out. If I put in 2, 4 to the second power is 16. If I put in 1, 4 to the first power is 4. Put in 0, anything to the 0 power is 1. Negative 1, if you forget, 4 to the negative 1 is the same thing as 4 to the, or 1 over 4 to the first power, which is 1/4. And you can see the pattern here. Negative 2 is going to be 1 over 16. So if I graph this, 2 is 16, so this is going to be way off the chart. 1 is 4, 1, 2, 3, 4. 0 is 1. I get 1/4, which is tiny, and 1/16, which is even tinier. My graph looks like this. It's just like the other graph, but in the opposite direction. And the reason why is because this number, remember the last one was a number between 0 and 1. This one's 4, so it actually goes in this direction, and it's actually much steeper. So now the question asks, which one will produce a point closest to the x-axis? You notice that it gets closer to the x-axis as my number gets more negative. So the answer, which will give me the biggest, or the point closest to the x-axis, the answer is going to be B, -1. Okay? So, to answer these questions, if the base of an exponential graph is between 0 and 1, then the graph is from left to right. So, actually I don't even know what word they want here. So, oh, I know what it means. It means that the graph is decreasing from left to right. I'm not going to be able to fit it, so I'm going to put dec. If it's greater than 1, then it's going to be increasing from left to right. We just did that graph, like so. Again, I can't fit increasing, so I'll just put inc. Okay. Now, to find x and y intercepts. Okay, some of you may have forgot about this, so that's why this is the review unit. To find the x-intercept, to find where it crosses the where it crosses the x-axis, what you have to do is let y equals 0. Okay, because the x-intercept, right, where it crosses the x-axis, y equals 0, and solve for x. To find the y-intercept, like where does it cross the y-axis, you need to let x equal 0, right, on this axis, x equals 0. And you have to solve for y. Okay. So for example, here's a graph of 1/7 x, and it says find the x and y intercepts, for example. Okay. So to find the x-intercept, let's make y equal 0 and solve for x. So what I'll do is 0 equals 1/7 to the x power. Okay. So you're saying, like, how do you solve this? As of right now, you don't know how to solve this. So I'm just going to leave this as D and E, and actually that's the answer. There's nowhere it crosses the x-axis. And you could tell, first of all, you could see this on a graph, but in all these exponential functions, just to review, it gets closer and closer and closer to the x-axis, but it never really touches. It just gets closer and closer. So for all exponential values, for the most part, as long as this isn't moved or adjusted, it never touches the x-axis. I forgot to fill in this part, just to review, if you forget what the name of the quadrants are. This one is 1, 2, 3, and 4. So just in case you forgot how to label the quadrants, that's how you label them. Now, find the y-intercept. Okay? To find the y-intercept, if you remember, I let x equal to 0 and solve for y. Alright, y equals 1/7 to the 0 power. Anything to the 0 power is equal to 1. The y-intercept is at 1. Where does the graph lies in which quadrants? If I graph it, I'm just going to not cheat, but just show you what it's going to look like. It's 1/7, so it looks like this. So the graph lies in which quadrants? It's going to lie in 1 and 2. And it says which points are on the graph, what you do is you plug in these numbers to figure out if it's true. So 0, 0, like if I plug in 0 here, do I get 0 for a y? No, you get 1. So this is not on the graph. 0 and 1/7. If I plug in 0 here, do I get 1/7? No. If I plug in 0, do I get 7? No. We already did this one. When you plug in 0, you're going to get 1. Okay. Now, we're going to skip over growth and decay real quick, but we'll see this later on in calculus, but I'm going to skip it over in your notes. What I want you to do last is how to solve equations, exponential equations. Like how do you solve for x if x is an exponential value? So what you have to do is first rewrite both sides so you have the same base. You can't solve unless you have the same base. And once they have the same base, set the exponents equal to each other. Okay? So let's look at this first example. This has a base of 2. This has no base right now. So what I could do is rewrite this. 1/16, you may not know this, but at the top of your head, that's the same thing as 2 to the 2 times 2 times 2, 2 to the 4th power. But since 16 is underneath the 1, 1/16 is the same thing as 2 to the -4 power. Now, do you see how the bases are the same? Now this is 2 and this is 2. So if these bases are equal, like both sides have to be equal, then all I have left is this has to be equal to this. So again, to slow it down, if this 2 is equal to this 2, then this 5x has to be equal to this -4. Like so. And then I solve for x. X is equal to -4 over 5. Okay. Next done. This one, bases are different. This is 9 and this is 3. I need to get them the same. This one's a bigger one, so I know I need to match 3. You should know that 9 is the same thing as 3 squared. Okay? And then I have that 4 plus x over here. And this one, this 3, is to the imaginary first power. Before I solve, well, first of all, this 3 is equal to this 3, so this has to be equal to this. Okay? So now I'm just going to solve for x. This is back to algebra. I can make this, I can multiply this out. This becomes 8 plus 2x. I could subtract 8 from both sides. And I could divide both sides by 2. The answer is -7 over 2. So I think you kind of get it. Let's do one last one. So this one, the hardest one, you'll notice that I have 16 and 8, not the same base. And 16 is not 8 to any power. I'm going to have to use a different power for both of them. So both of them are actually a exponent or multiplied of 2. So 16 is actually 2 to the 4th power. Ready? So we'll go like that. And 8 is 2 to the 3rd power, like so. So now 2 and 2, these are both equal. So this and this have to be equal. 4, 3 minus 2x has to be equal to 3 because the bases are equal. Again, solving for x, I'll multiply it out like so. I'll subtract 12 from both sides. And then I'll divide both sides by -8. Your answer is 9/8. Now, there are more difficult ones. We'll do more of these in class so that you understand. One of the things you may have forgotten how to do is, let me show you this one down here in the middle. Now, you're just like, wait a minute, how come this has a square root? Like, what do I do now? You may have forgotten, it's been a while since you took this, but the square root means to the half power. So this means 10x, and this is 1,000 to the half power. Okay, so if you see a square root, you take this value right here, which is 1, and put it up here, and then you take this value, this one is 2, and put it in the denominator. Okay, so just for example, I'm not going to do this problem, but what if we had a 3 and a 4 here? This would be 1,000th to the 3/4 power. Okay, but in this particular example, I have an imaginary 1 and an invisible 2, so that's why it's 1/2. I need to get my bases to the same. 1,000 is 10 to the 3rd power. Like so. This is equal to this. 10 is equal to 10, so this has to be equal to this. So x is equal to 3/2 when I multiply that out. Okay, so you could do that for all the other examples as well. So now the last part is solving for rational exponent equations, just so that you understand and remember how to do this. What you want to do is you want to get x by itself. So to solve it, you isolate the term that has a rational exponent, so get that term by itself, raise both sides of the equation to the reciprocal of the exponent, and then rewrite in radical form and evaluate if possible. So you're going to multiply or raise both to the reciprocal of the exponent. So this one, it says to the 1/4. The reciprocal of 1/4 is 4 over 1. Okay? So what I'm going to do is I'm going to raise both sides to the 4th power. You know that 1/4 times 4 is 1, so this becomes x, and your answer, you don't have to solve it out, is 7 to the 4th power. If I move on to this one, again, I need to get that term by itself, so the first thing before I start is divide both sides by 5. This becomes x to the 3/2, and dividing both sides by 5, I get 27, like so. So all I did was divide both sides by 5. Okay. Now this is by itself. Again, I raised to the reciprocal. The reciprocal of 3 over 2 is 2/3. So let me use a different color. So I'll raise both sides to the 2/3 power. Again, these ones cancel because they're reciprocals. That's the whole reason why these cancel. So I get x by itself. And then I'm going to put it in, see how this is a fraction? So again, I'll put the 3 out in front, and this is 27 squared. So I don't want to use up most of your time. So I'm going to do this last one for you all, because it looks like it's going to be the most confusing for most of you. So what I'll do is I'll subtract 2 from both sides. Okay. Now you'll see that I have a 3/4. This term is isolated, so I'm going to have to raise both of them to the reciprocal. The reciprocal of 3/4 is 4/3. So these cancel again because they're reciprocals, and it leaves me with x plus 7 and 8 to the 4/3. Okay. And now, to get x by itself, I subtract both sides by 7. Like so. And to make it neater, I need to put this in radical form. I have a 3 on the bottom, so that'll go in the front of my radical. So the answer is 3, or the cube root of 8 to the 4th power, and that's minus 7. So this should all be a review. It might be a little bit rusty for y'all since it's been a long time since you've done this, but this whole section is about exponential functions. It's one that we'll do a lot of calculus on later on in the year, so it's very important you know that. So you'll do the practice problems and let me know if you have any questions. So thank you for watching and have a good day.